Today's topic is NMR, Nuclear Magnetic Resonance. NMR, which is short form of Nuclear Magnetic Resonance, it is a branch of spectroscopy in which radio frequency waves induce transitions between energy levels of nuclei of a molecule. The magnetic energy levels are created by keeping the nuclei in a magnetic field. Without the magnetic field, the spin states of nuclei are degenerate, that is, possess the same energy. When a magnetic field is applied, levels get separated and radio frequency radiation can cause transitions between these energy levels. These are the energy levels of a nuclei of a molecule. When no magnetic field is applied, these are degenerated, possess the same energy, and when magnetic field is applied, these levels get separated and now becomes two levels. And radiation of radio frequency waves can induce transitions between these two levels. Quantum description of NMR. According to quantum theory, spin angular momentum of a nucleus is given by under root I plus 1 into h upon 2 pi. H upon 2 pi can be written as h cross, where I is the spin quantum number of the nucleus and h is Planck's constant. Spin angular momentum is I into h upon 2 pi according to old quantum theory, but it is now under root I plus 1 into h upon 2 pi. In place of I, we write under root I plus 1. If gamma is gyromagnetic ratio, then magnetic moment of nucleus can be written as mu equal to gamma under root I plus 1 h upon 2 pi. Gamma, gyromagnetic ratio, it is the ratio of magnetic moment mu and spin angular momentum. So if in spin angular momentum under root I plus 1 h upon 2 pi, if we multiply this by gamma, we find mu, magnetic moment of the nucleus. If a nucleus having a spin I equal to half is placed in a magnetic field H, the two energy levels become separate corresponding to Mi equal to minus half and Mi equal to plus half. Mi equal to minus half is for anti-parallel to the direction of magnetic field, and Mi equal to half, it is for parallel to the direction of magnetic field. the energies of two states with Mi equal to half and Mi equal to minus half are given by this formula E1 and E2. Formula for energy is this minus mu dot B. For B vector magnetic field we write here H. Value of mu is substituted from this formula. In this formula, we write in place of under root I plus 1 we write Mi, which have two values plus half and minus half, and substitute in this formula minus mu dot B, write H in place of B, and in place of mu we write gamma. Then we have under root I plus 1. In place of under root I plus 1 we write Mi, which is either plus half or minus half, and then we have H upon 2 pi. So we find two energies E1 and E2. For Mi equal to plus half we have energy E1 equal to minus half gamma H upon 2 pi into capital H, and E2 it is for Mi equal to minus half. This energy E2 is equal to half gamma H upon 2 pi into capital H. So energy is negative for Mi equal to plus half, and it is positive for Mi equal to minus half. So these are the two energy levels when magnetic field is applied. In the absence of magnetic field we have only one energy level. Upper energy level is for value of Mi equal to minus half, and lower energy level is for value of Mi equal to plus half. When Mi is plus half, energy is negative. When Mi equal to minus half, energy is positive. So two spin states of nuclei are now get separated when this magnetic field H is applied, and energies of these two energy levels are given by this formula E1 and E2. E2 is positive, so it is the value for upper energy level, and E1 is negative, so it is for lower energy level. Now the nucleus will be promoted from the lower energy state of energy E1 to the higher energy state of energy E2 by absorption of energy delta E. If nucleus absorb energy delta E, it can go from lower energy level of energy E1 to higher energy level of energy E2. If it absorb energy delta E, then this absorbed energy delta E must be equal to E2 minus E1. It means that the absorption of energy delta E equal to E2 minus E1 changes the magnetic moment from the parallel state to the anti-parallel state. Parallel state means Mi equal to half and anti-parallel state means Mi equal to minus half. The frequency nu at which energy is absorbed, it is resonance frequency. It is given by Bohr's relationship. We write h nu for delta E, energy absorbed. So we have h nu equal to E2 minus E1. This gives the value of frequency nu, which is equal to E2 minus E1 upon h. Now substitute the values of E2 and E1. E2 is half gamma h upon 2 pi into capital H. Then we have minus E1. E1 is minus half gamma h upon 2 pi h. Small h is cancelled out and we find this equal to gamma upon 2 pi into capital H. This is known as Larmor equation. From this equation, it is clear that the frequency absorbed by a nucleus in moving from one energy level to another is directly proportional to the applied magnetic field. Frequency nu is proportional to capital H. It is proportional to the value of applied magnetic field. In NMR, it is the absorption of energy which is detected. In order to determine the resonance frequency, the energy absorbed by nuclei is measured as magnetic field is varied. As magnetic field increases, precessional frequency increases. This frequency nu is known as precessional frequency, which is proportional to capital H, applied magnetic field. So when this capital H, applied magnetic field, is increased, this precessional frequency nu also increase. As magnetic field increases, precessional frequency increases, and when this frequency becomes equal to the frequency of oscillation field, that is applied field, transitions occur between nuclear states. The energy absorbed in this process produces a signal which is detected by the detector, and this signal is amplified and recorded as a band in the spectrum. This is the graph between absorbance and frequency nu. Absorbance, it is a measure of energy absorbed by the nucleus. Absorbance is log of the energy that is incident upon energy that is transmitted. So absorbance, it is equal to log of the ratio of energy, incident energy to transmitted energy, and it is a measure of energy absorbed by the nucleus. So we find this type of signal. When energy is absorbed, we find such a peak. When a nucleus with spin 3 by 2 is subjected to magnetic field, how does the energy level split, and what will be the energy of separation between any two adjacent levels? Now this is a question. For a nucleus with spin I equal to 3 by 2, magnetic spin quantum numbers Mi have these four values: minus 3 by 2, minus 1 by 2, 1 by 2, and 3 by 2. So if we have spin quantum number I equal to 3 by 2, values of magnetic spin quantum number Mi will vary from minus 3 by 2 to plus 3 by 2, minus I to plus I. Since I is 3 by 2, Mi is values of Mi are from minus 3 by 2 to plus 3 by 2 with a difference of 1. So we find these four values. Minus 3 by 2, if we add 1, we get minus 1 by 2. If we add 1, we get plus 1 by 2, and if we add 1, we get 3 by 2. So if I is 3 by 2, Mi have four values: minus 3 by 2, minus 1 by 2, 1 by 2, and 3 by 2. Values of Mi are from minus I to plus I with difference of 1. So these are four values of Mi, and the energies of these states are given by this formula: E1, E2, E3, and E4. For Mi equal to minus 3 by 2, for Mi equal to plus 3 by 2, we have this value E1, that is minus 3 by 2 gamma h upon 2 pi into capital H. So this is the value of energy for Mi equal to plus 3 by 2. This energy is minus 3 by 2 gamma h upon 2 pi h. This E2, it is value of energy for Mi equal to plus half. For Mi equal to plus half, energy is minus half gamma h upon 2 pi h. This is for Mi equal to minus half, and this energy is half gamma h upon 2 pi h. And for Mi equal to minus 3 by 2, we have energy E4, which is equal to 3 by 2 gamma h upon 2 pi into capital H. The energy of separation between any two adjacent levels, E4 minus E3, it is equal to E3 minus E2, it is equal to E2 minus E1, and the difference of two adjacent energy levels, if we subtract energy of two adjacent levels, we find this difference equal to gamma h upon 2 pi into capital H. Here gamma is gyromagnetic ratio and H is the magnetic field.